By the end of this lesson, I will be able to apply the Pythagorean theorem in real-world situations. Essential question: how do I apply the Pythagorean theorem in real-world problems? So this week we've already had exposure on the Pythagorean theorem. We did a couple of rotations to just help us apply the theorem that we've learned from the video. So what exactly is the Pythagorean theorem? Just a quick review. What does it say when the hypotenuse is missing? It says, I'm going to write it down here because I write kind of large. It says a squared plus b squared equals c squared. And what does that mean? If you have a leg of a right triangle and you raise to the second power, you have another leg and you raise to the second power, find the areas of those two, and you add them together, it equals to the longer side of the right triangle, which is the hypotenuse squared. And it only works for right triangles. So what is the converse of the Pythagorean theorem? So that occurs when a leg is missing. What do you need to do? Because when we had the hypotenuse missing, we had to add. But when we have a leg missing, you have to, that's right, subtract. So what does the formula tell us to do? You have the hypotenuse. You subtract it from a leg. You have the hypotenuse squared, and you also have to subtract it from a leg squared. And it equals to the other leg squared. Same thing works if it's the other leg. You can write it as c squared minus b squared equals to a squared. These are the formulas that we've been using. So let's take a look at some strategies you would use to actually solve some word problems. You've all have exposure to word problems. You've done this before since kindergarten. And they always tell you to read it carefully, underline or annotate, that's what they call it now, underline important information. And if it's possible in math, draw a diagram, draw a picture. And this all works out for the mathematical practice of making sense of the problem. Draw a picture. So let's take a look at this word problem. So you bought a new laptop. The screen is 10 inches long, and the diagonal of the screen is 13 inches long. How tall is your laptop screen? So, of course, I want to underline important information. That's what I'm going to do right now. I believe the 10 inches is important. Diagonal is very important. And then we have this 13 inches. That is the measure of the screen. Okay? Now, I want to draw a picture. So why not draw a picture of... Let's draw a picture. So we're talking about a laptop, so it's going to be in, let's undo that one. It's going to be some box shape. And then we talk about a diagonal, so I'm going to draw a diagonal from one vertex to another part of the vertex of that figure. Now I'm going to label my dimension. Got my picture going on. It says the screen is 10 inches long, so here we go. We got 10 here, 10 inches. And then the diagonal of the screen is 13 inches. And we're trying to find how tall it is. So we're trying to find its height. I'm going to put down a variable. If it's unknown, why not put down, why not put down a b? So I'm looking at the shape. Kind of looks like a what? A right triangle. So what can we do to actually solve this problem, to figure out the missing leg? What theorem did we just learn about? Ding, ding, ding. Yes, indeed. Pythagorean theorem. What is missing? The leg, so I need to subtract. So I'm going to do 13 squared minus 10 squared is equal to that missing leg squared. 13 times 13, pull out your calculators, is 169. 10 times 10 is 100, and it equals to the other leg squared, which is b squared. So now I'm going to subtract 169 from 100. I'm going to get 69. Uh-oh, am I done yet? Nope, we have the square. How do we get rid of the square from the equation? What is the inverse of squaring a number? That's right, square root on both sides. Now, we already know that the square root of 69 is a non-perfect square. So it's in between 8 and 9 because it's 64. The square of 60 is 64 and 64 and 81. So what is the square root of 69? It's closer to 8. So I'm going to put in my calculator. So it's about 8.03. I'm going to round to the nearest tenth, and I'm done. You have a couple problems to do with your group table mates, and that's about it.